Hi folks, in this video I explain how to use the proof machine for first order logic. The proof machine now works for the entire first order logical system, all the quantifier rules and the identity rules. There's just one restriction on how it works, which is you cannot use predicates and names in long form, you have to use short form. For example, if I write guilty Pia, you'll see that this is telling me that there's a syntax error here. Instead, what I have to do is I just have to use the short form names and predicates like G of P. Now you can see that this works properly. It's not getting graded out as a syntax error. So if I have P has property G, I could say exists an X that has property G, and this would be the existential intro rule. So you can see that the existential intro rule works just fine. Let me also demonstrate how some of the other rules work. We can now do existential elim from this next, let's say. So in order to do that, we need to talk about an arbitrary name like the name n, and I use this @n notation and then put a space here. I'm just going to put g of n. So this is some object that has property g. Now I'm going to do existential intro just to show you how variable switching would be proven. So now that I know that n has property g, I'll just say ey existential intro on 3. And then this is going to allow us to write ey and we'll see that existential elim works just fine. So this is existential elim. What I need to do is cite number 2 and then 3-4, and all of these lines will check out. So it has all of the existential rules are working perfectly. Let's just look at the universal rules real quick. Let's just say I know that everything has property G. So for all x, G of x, then I could also just say G of A, for example, and I can do universal elim. We can also do universal intro. It's going to be starting a subproof with @n, and in this case, all we put there is the declaration that n is arbitrary. We don't put any formula here. Now we can instantiate line 1 for the name n. So let's just do universal elim for the name n. And now that I've proven that, I'll just do variable switch here, something simple for all y, G of y. And you can see that universal intro works as well. I just cite this subproof 2-3. Even the identity rules work too. So let's just do something like I have A equals A, or let's say I have A equals B. Okay. Now what I want to do is I'll just introduce A equals A, identity intro. And that's the one rule that doesn't, the one rule with a symbol that does not require any line numbers. So there's no semicolon or anything with that rule. And then let's say that I want to do an identity substitution here. I'll just start a new letter. Let's just say I have a relation like R of AC. So you can see that it works for polyadic logic. I can use predicates of any size arity, and it's going to work just fine. Let's make this a premise. And now I can do identity elim on those, citing 1 and 2. The sentence, of course, I can, wherever I have an A, I can put a B. So I'm going to write R of B, C. And hey, that checks out too. So you can see that it's got all of the intro and elim rules for the quantifiers and the identity predicate. And it works for one-place predicates. It works for relations and everything. So all you need to remember is to use short form names and predicates, and this system should work great. Of course, I just created this thing. So if you encounter anything that you think is a bug, please send me an email at iSchnee. I'll write it here, iSchnee@uw.edu. And because it's perfectly possible that there's some bugs in there. And of course, it works completely well with all of the Boolean and propositional rules too. Like besides, after I prove R of C of BC on that line, I can now write R of BC or P, and that would be disjunction intro citing line 3. So you can see that this system works just like FOL has all of prop and bool in it. So does the proof machine. So this will give you the ability to check all of your proofs and get feedback in the message area for what is going wrong. Okay, thanks.